Hello guys, welcome to this grade 11 Euclidean geometry lesson whereby we will be doing this practice problem. So this is my favorite topic. You guys probably know what I'm going to talk about since we will be doing this grade 11 Euclidean geometry. Of course, I will be talking about Dr. Cape Town, DRCPT. That is a very powerful technique that I will always recommend to some students who are doing grade 11 Euclidean geometry. I will always recommend the technique DRCPT, Dr. Kepta. This is a very beautiful technique that you will use, guys. So let me explain how this Dr. Cape Town techniques work. We have letters here. So in order for you to quickly remember it, if maybe you happen to forget it in the exam, just think of Dr. Cape Town. Then you will write it in short, DRCPT, where the D is the diameter. The D is the diameter. The R is the radius. The C is the cyclic quad, and P parallel lines, and T is the tangent, right? So you guys know what a diameter is, you guys know what the radius is, you know what a cyclic quad is, what the parallel lines are, what a tangent is into the circle. So you will look at your diagram, look if there is a diameter, you apply anything that you know about the diameter, that a radius is 2 times, is a half of a diameter, or the diameter is 2 times a radius, or that theorem that says an angle subtended by the diameter or angle in a semicircle. Then we also have R, which is the radius. You apply everything that you know about the radius. The radius is perpendicular to the tangent, and then the radius bisects the chord if it is perpendicular to the chord, and then which one again? About the radius. Oh, it's just that it's that radii are always equal into a semicircle. We have seen the cyclic quad. You know the properties of the cyclic quad, that opposite angles of a cyclic quad are supplementary. Exterior angle is equal to interior opposite angle of a cyclic quad. Angles in the semicircle. No, I'm sorry. Angles subtended by the same diameter. And then we have P parallel lines. We're gonna use the technique maths is fun, where we're gonna use these 3 reasoning, corresponding angles, alternating angles, and co-interior angles. We have a tangent. We're gonna use the tan chord theorem, and the tangent is perpendicular to the radius, or tangent is perpendicular to the diameter. Okay, now, guys, after using this technique, ensure that you always read the statement that you are given, just to be sure that you understand what you are given, so that you're going to use every information that you are given as a tool to help you get what you are required to do. So question 9, let's have a look on this question. Question 9.1 says to you, or to me also, complete the statement so that it is valid. Okay, now, the line drawn from the center of the circle perpendicular to the chord. This is theorem 1, right? So if we've got the center, we've got a chord, we've got the line now that is drawn from the center all the way perpendicular to that chord. What do we mean by this perpendicular to the chord? Perpendicular to the chord, meaning that they at the intersection point, they intersect at a right angle. What is a right angle? A right angle is an angle that is exactly equals to 90 degrees. I'm sorry for that. That is exactly equals to 90 degrees. So if this line is perpendicular to that chord by theorem 1, this line bisects the chord. What do we mean by the word bisect? We mean that it divides this chord into two equal parts. Therefore, this part is equal to this part, right? So now you will complete the statement. The line drawn from the center of the circle perpendicular to the chord bisect the chord. Bisect the chord. Then you get your beautiful 1 mark. Good. Now let's go to the next question, 9.2. They are saying to us, in the diagram, O is the center of the circle. Where is the diagram? Oh, here is the diagram. O is the center of the circle. DE is the diameter, and we can see that D is on the circumference, E is on the circumference as well, and our line passes through the center. Therefore, indeed, DE is the diameter, and DE is perpendicular to the chord PQ. Okay, now it takes us back to 9.1. There is a line drawn from the center O to the chord, and it is perpendicular to this chord. What does that mean? It means that this line bisects this chord. Therefore, PC is equal to CQ. It is perpendicular to the chord at C. Okay. DE is 20 centimeters, meaning the diameter is 20 centimeters. If the diameter is 20 centimeters, what is our radius? Our radius is half of the diameter. Therefore, OE will be 10 centimeters. Also, OD will be 10 centimeters because the whole of DE is 20 centimeters. Okay, now CE is 2 centimeters. Now, this portion here, this one, CE is 2 centimeters, right? Okay, now we are done with our analysis using the technique and the information that we are given there on the statement. Now, we can freely dive into the problems and see what we are required to do. Okay, let's go. Calculate the length of the following with reasons. So this is very, very important, guys, in Euclidean geometry. In Euclidean geometry, you need to provide the statement and the reason in order for you to get the full marks. If maybe you say AB squared is equal to BC squared plus AC squared. Why do you say this? This is the only statement. You need to provide the mathematical valid reason. Why do you say this is equal to that? Then, for example, you say that because I used Pythagoras theorem. You get a mark for the statement. You also get the mark for the reasoning. I hope you guys get that. So that with reasons is very, very important because without reasons, you won't get a full marks. Okay, now we want to calculate the length of OC with reasons. Okay, now OC is from here to here. Now, what do we need to do? Okay, in order for us to find OC, what are we first going to do? We are going to find OE. Then we will say that OE is equal to 20 divided by 2, which is 10 centimeters. Why? Because OE is a radius. So OE is half of DE. That was the diameter, right? Okay, now we have OE. We want OC. Let's go. OC is going to be equal to OE minus CE. CE was given, right? Yes. Now what is OE? OE is 10 centimeters. What is CE? CE is 2 centimeters. Then I get 8 centimeters as the length of OC. Just like that. I hope it makes sense. So I will erase this just to use this white space to answer also the next question. I hope you guys get that. Now let's go to the next question, 9.2.2, where now we are required to find the length of PQ. Now let's highlight that OC. Now we have this OC here as 8 centimeters. Okay, let me erase this. There we go. Okay, now we want PQ. PQ is this chord here. It is this chord here. Now, look at this. How can we find PQ? So now how about we construct some line here that joins O and P. That joins O and P. Yes. And what is that line? That line, it is radius. Why? Because it is from the center all the way to circumference. So what is the length of OP? And then you will say OP is equal to OE is equal to 10 centimeters. What is the reason behind that? They are all radii, right? Yes. Now we have 10 centimeters for the OP. Okay, now we can use a Pythagoras theorem because now our triangle OCP is a right-angled triangle. So guys, you need to note that Pythagoras theorem is only applicable on a right-angled triangle. What is a right-angled triangle? A right-angled triangle is a triangle with a right angle. Remember I said a right angle is an angle that is exactly equals to 90 degrees. So now let's go for our Pythagoras theorem. We will say OP squared is equal to OC squared plus CP squared. Why? Why do I say OP squared is equal to OC squared plus CP squared? Because that is the theorem of Pythagoras. Pythagoras theorem. Now, let us make our substitutions. So what is OP? It is 10, then we square it. What is OC? It is 8, then you square it. What is CP? CP is the one that we are looking for. And then now 10 squared is 100. 8 squared is equal to 64 plus CP. Now CP squared. Now here you do your beautiful algebra. Now we are making CP subject of formula. We are going to take this 64 to that side because it was positive. Now it is going to be negative to that side. 100 minus the 64 is equal to CP squared, right? 100 minus 64 gives me 36 is equal to CP squared. Now, what do we want? We want CP, not CP squared. How can we make this CP subject of the formula? We want to remove that square. Now we will put the square root. Remember, since this is an equation, whatever you do on the left-hand side, you also have to do on the right-hand side. Whatever you do on the right-hand side, you also have to do on the left-hand side. So if you put the square root on the right-hand side, you also have to put the square root on the left-hand side. Now, CP is equal to plus or minus 6. Now, can the distance or the length be negative? No, the length cannot be negative. Now, we will only choose the positive answer. Now, the CP is only positive 6 centimeters. Just like that. Now, this is only CP, right? This is only CP. Now, we only have this part. Remember the question required us to find the whole of this chord, the PQ. Now, let us go for CQ. We will say CQ is equal to 6 centimeters. Then now, your reason, you will state this reason from the theorem 1, that the line that was drawn from the center of the circle perpendicular to the chord bisect that chord. Now you will come to the conclusion that PQ is equal to CP plus CQ. And then that is 6 plus 6, which is equal to 12 centimeters. Then you are done just like that, answering 9.2.2. I hope it makes sense to everyone, guys. Now, let us go to the next question, which is question 10. So question 10 says to us, in the diagram, O is the center of the circle. A, B, and D are points on the circle or on the circumference, right? Yes. Use the Euclidean geometry method to prove the theorem, which states that angle AOB, which is this angle, is 2 times angle to ADB. ADB is that one, which is angle at the center is 2 times angle at the circumference. Oh, so guys, I wanted to tell you that always you will find the proof of one of those theorems, whether you are required to prove theorem 1, you are required to prove theorem 2, you are required to prove that angle at the center is 2 times angle at the circumference, whether you are required to prove that opposite angles of a cyclic quad are supplementary, but the proof will always be there. He might even require you to prove that a tan chord theorem, that an angle between the chord and the tangent is equal to that interior opposite angle that is opposite the chord. So you need to know how to prove those theorem, guys. Now, let us see how we can prove this one that says angle at the center is 2 times angle at the circumference. Now, the first thing that you will do, you will be given the answer sheet. And then on that answer sheet, your answer sheet will be having a diagram like this. Now, using your pencil, you will construct the line there that joins DO, and then it passes there, and DO maybe stop somewhere there, right? Yes. And now you will maybe let the end point of this constructed line be E, maybe, right? Now, we are going to have these two triangles. Let me maybe use two different colors. We are having this red triangle and the blue triangle here. Good. Now we are going to use these two triangles. Now, you will say because there on your answer sheet, maybe I'm not sure if it is allowed to use crayons, but to be safe, avoid using, maybe you can use them just to highlight, but whenever you answer the questions, you will say now, in a triangle OBD, OBD, which is the blue one, triangle OBD, right? We are going to work with that triangle now. You will say OD is equal to OB, right? OD is equal to OB. Why? Because remember, this is Euclidean geometry. We need to support. Why do we say OD is equal to OB? Because they are both radii, which is the plural of the radius. Radii. This is the line from the center to the circumference. The line from the center to the circumference. Right? I hope that makes sense, guys. Now, EOB, the angle EOB. Remember, we have this property when we talked about the triangles, that if you have a triangle like this and some line that is extended to go all the way to the right there, this angle will be equal to this angle plus this angle here, right? Yes. Now, you also need to know that there exists a triangle that is called an isosceles triangle. What is an isosceles triangle? Isosceles triangle is a triangle that have two equal sides and two equal angles. So once a triangle have two equal sides, these angles, I mean, will also automatically be equal. So since in a blue triangle we have OD equal to OB, automatically this angle here will be equal to this angle here, right? Now, if you let this angle to be x, angle B to be x, then angle O D, angle ODB, O there at D, then goes to B, will also be x. Why? That is the base of an isosceles triangle. Base of an isosceles triangle. So now, we will say an angle EOB, which is this angle. Now we are using this property. We are taking it there. We will say EOB is equal to 2 times angle ODA. ODA, right? Because now, where does this come from? Because we'll say this angle EOB is equal to, okay, I put the head to show that we're talking about the angle, is equal to angle ODB plus angle OBD. OBD, right? Now, what is OBD? What is OBD? It is x. What is ODB? It is also x. Now, x plus x is equal to 2x. Now, where was x? X was here. You can say ODB. I'm sorry, not ODA. ODB. We are still on the blue side. ODB. I hope it makes sense. Now, also on the right, on the left-hand side, on the red triangle, you're going to do the same thing. Now, you will say OA is equal to OD. Why? Because those are the radii in triangle AOD. And then now you will have angle EOA. There at O is equal to 2 times not A, it's ODA. It's ODA. There at D. There at D. Okay, now let's proceed with it. Now, an angle AOB, an angle AOB, there at O. This whole angle here, it is going to be equal to this part plus this part, which is going to be EOA plus EOB, right? EOB, right? Now, what was EOA? EOA is 2 times ODA. There at D plus. What is EOB? EOB is 2 times ODB. Just like this. Now, let's go. Can take a 2 as a common factor here. Now, 2 inside the brackets, you will be left with ODA plus EOB. EOB. I don't know what I wrote here. EO. Whew, my bad. No. It's not supposed to be. We said EOB is ODB. So it will be ODB here. And then EOA is equal to 2 times ODA. Okay. Now, this will be equal to. Now, ODA is that part there, which is this one. And ODB is equal to this part of which now this sum is equal to ADB. Now you have proved that an angle AOB is equal to 2 times ADB. You have proved that an angle at the center is 2 times angle at the circumference, right? So guys, you need to ensure that you visit all the proofs of all those theorems that we talked about in a grade 11 class. Otherwise, I guys hope that everything made sense to you. Now we will end here for this lesson, and then now I will see you guys on the next one when we are continuing with this practice questions of Euclidean geometry for grade 11. Thank you guys. I will see you in the next one.